Now, our next concept is moment of force, or some people also call it torque. How we can define it? Now look, moment of force or torque is a product of the magnitude of the force and the perpendicular distance of the force from the pivoted point. Now what does it basically means? Let us understand through an example. Here we have a screw and we want to open it through a spanner. Now we are applying force here. For instance, from a distance d from the screw, and the screw is fixed at a point. This point is called pivoted point. Okay, pivoted point basically means fixed point. A point where a body is fixed is called a pivoted point. Now we are applying a force of some magnitude, say 10 Newton or 15 Newton, from a fixed point. Now what will happen? The applied force will start rotating the screw. Okay. Now this is the effect of moment of force. Moment of force, what it does? Now moment of force rotates a body. Okay, from a fixed point. Moment of force rotates a body from a fixed point. Now, now let us understand another thing. Suppose we apply the force here. Can we rotate the screw? Yes, we can. But we need the magnitude of force larger than here. Suppose we apply the force here. Can we rotate the screw? Yes, we can. But we need much more force than here. So, there is one thing to be noticed, that moment of force or torque depends on two things. Number one, the magnitude of the force applied. The large amount of force I can apply, the easily I can rotate the body. And number two, the perpendicular distance from the force and the pivoted point. Understand the fact? Greater the distance, lesser the force. Okay, if we apply the force here, we can rotate it easily. So greater the distance, required force is less. So these are two factors on which moment of force depends. Moment of force mathematically expressed as F into D. F is the force applied and D is a perpendicular distance from the pivoted point. Okay. Now, what is the unit of moment of force? As we can mathematically write, moment of force is force into displaced distance. So, it is unit of force into unit of displacement or distance. Now in SI, unit of force is Newton and unit of distance is meter, so it is Newton meter. And in CGS, we have learned previously that unit of force is dyne and unit of distance is centimeter, so it is dyne centimeter. So there is a relation between CGS and SI unit of moment of force. What is? Let us derive it. Now we know 1 Newton meter, that is SI unit of moment of force or torque, is 1 Newton into 1 meter. Previously we have learned that 1 Newton is equals to 10 to the power 5 dyne and 1 meter is 100 centimeter. So it is become 10 to the power 7 dyne centimeter. Okay, so 1 Newton meter is 10 to the power 7 dyne centimeter. And let us do a numerical. a basic numerical. Suppose we have a spanner here, screw here, and we are applying a force of 15 Newton through a spanner, and the handle of spanner is 20 centimeter apart from the screw or from the pivoted point. Now question is, how much moment of force is producing? This is the question. The formula is as simple as that. Moment of force or torque is force into displacement. Force is 15 Newton and displacement is 20 centimeter. So we have to make it in SI meter. So 20 centimeter is 1/5 meter. Just substitute the values, we get 3 Newton meter. This is the moment of force, required moment of force. Okay, thank you.